Example the last. Find the third Taylor polynomial for f of x equals sine of x expanded about c equals pi over 6. Let me go ahead and show you what a picture of this looks like. So we've got our sine graph, and we've got this cubic equation that we're trying to use to approximate it. Let's get the equation for that thing. Okay. Nope, not McLaurin. We're going to center this thing about pi over 6. Hopefully you remember your unit circle. Example 7. Function. And then we're going to evaluate those functions at c equals pi over 6. Our function we're starting off with is sine of x. And so we want the sine of pi over 6. So I'm going to draw myself a nifty little unit circle. Here's our pi over 6. The sine of that, of course, is half. It's the short one. And then let's find its first derivative, which would be cosine of x. And the first derivative evaluated at pi over 6, this time it's the longer one down here, which is square root of 3 over 2. A couple more to go. So then our second derivative is going to be negative sine of x. So second derivative evaluated at pi over 6. Same thing that we got over here at pi over 6. Sine of pi over 6 was a half, just got to make it negative. One more, just one more. Home stretch. That'll be negative cosine x. And so the third derivative evaluated at our center point, pi over 6, is equal to negative square root of 3 over 2. All right, we have all the information that we need to build our third degree Taylor polynomial for sine of x centered at pi over 6. We don't have to mess with all of the ones that come before it. We're just going to go straight to it. So p sub 3 of x, put an x in there, come on, is equal to, and now remember we're centered at this pi over 6 here, so it's not just going to be x squared and all of that stuff. We have to translate it. Okay, so we start with our function value, which is a half, plus I have the square root of 3 over 2, that's this derivative, divided by 1 factorial, if you wanted to, times x minus pi over 6 to the first power. Just keeping the pattern going. And then we have negative 1/2 over 2 factorial times x minus pi over 6 to the second. And then we have one more, negative square root of 3 over 2 over 3 factorial times x minus pi over 6 to the third. Maybe I simplify, clean this up just a little bit. You didn't really have to. It's not crucial. If it was a multiple choice question, of course, you would probably want to, so you can match up some answers. 1/2. So this 1 factorial that's on the bottom here is just 1, so that 2 is going to shoot down there, and I've just got square root of 3 over 2 x minus pi over 6 to the first power. 2 factorial is 2. Bring the other 2 down to it, so it's 1/4 x minus pi over 6 squared. And then our 3 factorial is 6. 3 times 2 times 1. And then multiply it by the 2 that's up here at the top. That's going to be 12. So square root of 3 over 12 x minus pi over 6 to the third. There we go. Lovely. There is our third degree Taylor polynomial for the sine of x centered about pi over 6. And of course, I mean, we saw the graph of that thing. It hugs it. Whoops, that's the calculator. All right, it hugs it pretty nicely, for a little bit at least. All right, so that concludes the first objective about using Taylor polynomials to approximate our functions. And what we discovered is that what you get to do is you get to take a whole bunch of derivatives, evaluate those derivatives at your center point, and then write your generic terms as the nth derivative evaluated at your center point divided by n factorial times x minus your center point to the nth power.